In our last video, Katie used R to show us our car dataset. Now we need to learn how to model this car dataset using multiple linear regression. This can often be a confusing topic, but thank God for Griselda. She's going to teach us all about the theory.
That's right, Brittany. I will teach you about the theory behind multiple linear regression with interaction. It can seem a bit complicated, but don't worry. We will start with a very basic model, also known as a simple linear regression model, and build from there. By the end of this video, you will understand the basic building block of regression analysis, the simple linear regression model. We will then climb up the pyramid to multiple linear regression until we reach the peak, which is multiple linear regression with an interaction term included. Let's go over our schedule for this video. We will start at the base of our pyramid with simple linear regression. I will show you how to interpret the beta coefficients, as well as the R output. Next, we will step up to multiple linear regression. Before showing you how to interpret the beta coefficients and R output, I will digress to talk about binary variables and how they affect the model. Finally, we reach the top of our pyramid, multiple linear regression with interaction. Again, we will show you how the expected or mean response changes depending on the values of the binary variable. We will interpret the beta coefficients, and we will interpret the R output. But before all this, I will show you some graphs to help you visualize and understand interaction effects. I'll take this moment to point out that for the purposes of this video, x1 has been centered. I'll explain what this means and what it implies later on. But just keep this in mind as you are watching. A simple linear regression model uses one independent variable, x, to predict the mean response, y. Suppose we want to determine the horsepower of a set of vehicles, and the only information we have available are the miles per gallon, or mpg, for each car. Using simple linear regression, we can set up horsepower as a linear function of mpg. Our goal is to find good estimates for the betas, which are the unknowns. x1, on the other hand, represents our known values for mpg, which can be obtained from the dataset. This first equation represents our uncentered model where x1 is just the observed mpg. However, since we have centered mpg, we should use this second equation. At this point, you're probably thinking, please explain the centering stuff. So here it goes. When we say that mpg has been centered, we are simply saying that a constant, usually the mean, has been subtracted from each mpg observation. In our data, mean mpg has been subtracted from each observation of mpg. That is why we have x minus x bar, where x bar represents the mean of x1, or mean mpg. So remember, if you have an uncentered mpg, just use x1. If you have centered mpg, use x1 minus x bar. I want to take a moment to clarify the difference between categorical and continuous variables, because it relates to an important point I want to make regarding centering, and also because it is essential to understanding regression analysis. Categorical variables are variables that have a finite number of categories, or distinct groups. Examples of categorical predictors include gender and smoking status. It is helpful to think of them as variables that describe qualities, or characteristics. For our model, cylinders is the categorical variable. A car may have the quality of having either 4 or 8 cylinders. Continuous variables, on the other hand, are numeric. Examples include age, weight, and height. In our model, the continuous variable is miles per gallon. It is important to note that the response variable for linear regression must be a continuous variable. Now that we got that out of the way, I can finally warn you that you can only center continuous variables. It does not make sense to center categorical or qualitative variables. It doesn't make sense to subtract mean female from female. What is even the meaning of mean female? It just doesn't make sense. You may be wondering, why would I ever center a variable? You can center continuous predictor variables to lessen the correlation between a multiplicative term, such as an interaction, and its component variables, or the ones that were multiplied, or to make interpretation of parameter estimates meaningful or more meaningful. I included equations for both uncentered and centered MPG to help you understand the concept of centering, but from now on, I will only be showing the centered versions. Here is the simple linear regression model with centered MPG that we saw in the previous slide. The independent variable y represents horsepower, and the dependent variable x1 represents MPG. When interpreting the betas, we have to keep in mind that x1, or MPG, has been centered. This means that the mean MPG was subtracted from every observation of MPG. Beta 0 represents the y-intercept. It is the mean horsepower for a car with average MPG. Beta 1 is the change in the mean horsepower per unit increase in average MPG. But how do we know this? Let's take this step by step. First, I will be showing you how to interpret beta 0. So notice that in this simple linear regression function, we have only one continuous predictor. Algebraically, beta 0 represents the y-intercept, and beta 1 represents the slope of our line. The y-intercept is simply the value of y when x1 is equal to 0. I want you to pause the video to think about the following question. Would it be correct to say that beta 0 is the mean horsepower when MPG is equal to 0? In other words, would it be correct to say that beta 0 is the mean horsepower for a car with 0 MPG? By the way, notice that such a car is non-existent. So, what do you think? The answer is no. That would be the correct interpretation of beta 0 if MPG was not centered. However, since MPG is centered, beta 0 represents the mean horsepower for a car with average MPG, and such a car does exist. See how centering has made the interpretation of beta 0 meaningful and easier to understand? Now let's move on to the interpretation of beta 1. Remember how we said beta 1 is the slope of the line? This simply means that beta 1 is the change in mean horsepower if we increased MPG by 1 unit. But remember, we don't simply have MPG here, we have centered MPG. So in this case, beta 1 represents the change in mean horsepower if we increased average MPG by 1 unit. Now I will show you how to interpret the R output when we run the equation from the previous slide. The table shows us that the estimate for beta 0 is 105.6, and the estimate for beta 1 is negative 4.4. These values tell us that the mean horsepower for a car with average MPG is 105.6, and that the change in mean horsepower when we increase average MPG by 1 unit is negative 4.4. A simpler way of saying this is that mean horsepower decreases by negative 4.4 units when we increase average MPG by 1 unit.